Alright guys, now we're going to the third video today, which we will be finishing up this chapter today. So, I didn't say on the last video, but I am going to say on this one. I'm only doing a couple problems for you, and then if you need some extra help, just let me know. But I want you to try to do the other problems by yourself and then submit them. I'm kind of getting you prepared. We are going to do a review tomorrow with some of the review problems. And then our test is going to be Wednesday. So that's pretty much our plan for the rest of the next couple of days. So let's go ahead and get started with it. So I'm going to start with the practice problem that they have, or the example problem on page 212. So it says, a talented jogger can keep as many as 12 identical balls in the air at one time. Well, I am not that special. Suppose each ball has a mass of 0.20 kilograms, okay? Of the two balls have elastic head-on collision during the act. The first ball moves away. So, the mass of the first ball and the second ball is 0.220 kilograms. So, it says, after I had the head-on collision, the first ball moves after the collision to 3 meters per second. That's the velocity initial, okay? And to the right, the second ball moves away at a velocity of 4 meters to the left. So since this one's to the left, this is a negative number. Since it's to the right, is a positive number. And so it says if the first ball velocity before the collision is 4.0, okay, that's when we have it first. It's saying, all right, so what is the velocity of the second ball after the collision? So the first thing we're going to do is see what we have given. Here's what we're given here, which we just went over. We're looking for the velocity of the second ball initial. Okay? So the next thing it tells you to do is do a plan. So here, my plan is, I wrote down my equation, but I wrote down what I'm looking for in red so I can separate it. So here's my original equation. Here's where I'm changing it, because I'm taking the mass out because it doesn't matter. And then I'm rearranging my equation so that I can solve for number 3. So, velocity to initial is 3.0 meters per second, and I'm subtracting it by 4.0 meters per second, and then I am subtracting by the negative 4.0 meters per second, which is 3.0 meters per second to the right. The next thing it does is it pretty much tells you how to check your work. And it was telling you how you need to do that. I'm not going to go over that because I'm going to go ahead and get straight into the problems. So let's go on to problem number 1. So problem number 1 says a 0.015 kilogram marble. There we are. That's our mass. Slides to the right at 22.5 meters to the... Sorry. I've got to figure out how to get these things off. 2.25 meters to the right on a frictionless surface, making an elastic head-on collision with a 0.15 kilogram marble moving to the left at 18 meters per second. And so, first of all, to the right is positive, to the left is negative. It says after the collision, find the first marble moving to the left at 18 meters per second. So my velocity 1 final, that means my first marble, has a negative 18 centimeters and it's going to the left, so that's why it's negative. So A says find the velocity of the second marble. So to be able to find the velocity of the second marble, what I have to do is I'm just taking my formula, m1 times v1 initial plus mass 2 velocity 2 initial minus mass 1 velocity 1 final divided by mass 2. So what I'm going to do here is since mass 1 and mass 2 are equal, I'm just changing this to a linear equation. So I'm just going to take 22.5 centimeters, I'm going to add it to negative 18, and then subtract it by negative 18, and I get 22.5 centimeters to the right. So that's my velocity to final. But then the second part, here we go again, it's asking us to verify the answer by calculating the total kinetic energy before and after the collision. So the kinetic energy initial. And if I'm doing that, I'm doing the same math that I did before. Okay? So, on my calculator, what I'm going to do is, this is a fraction, alpha y inner. I'm going to do 1 over 2, and I'm going to do a, whoop, let me clear everything. Alpha y inner, 1 over a 2, right? And then it tells me that I need to multiply by 0.015, and I'm going to close my bracket, open my bracket, 0.225, close my bracket, but look, that's a square there. So I'm going to put a square. After that, it tells me to add, so I'm going to add, and then I'm going to do 1/2 again. So I'm going to do alpha y inner, 1 over my 2, back over again. I'm going to do my 0.015. I'm going to close my bracket, and then I'm going to do my negative, right? 0.180, close bracket, and I'm going to square it because that's what it says to do. So I got 6.2 times 10 to the negative 4. Then I'm going to do my same thing, except this time I'm going to do my kinetic energy final. I'm going to plug it in just like I plugged it in before, right? And then I get the answer. So that is the question number 1. This part of this section should just be just like this one, except you're using different numbers, so I'm not going over that. So then number 2 says, suppose speed as high as 273 kilometers per hour, that's my velocity initial, was recorded for a golf ball. Suppose a golf ball whose mass is 45 grams is moving to the right at 273 kilometers per hour and strikes another ball at rest. Well, my velocity 2 is 0. It's after the perfect elastic collision, the first ball moves 91 kilometers per hour. Well, he's moving, and it's going to be a negative, right? And to the left, and the second ball moves 182 kilometers to the right, which is positive. What is the mass of the second ball? So what I'm going to do is I'm going to do the momentum of collision equation, which is my mass 1, velocity 1 initial, plus my mass 2, velocity 2 initial, equals mass 1, velocity 1 final, plus mass 2, velocity 2 final. So what am I looking for? I'm looking for the mass of the second one that it hit. To be able to do that, I'm going to change my equation and get M2 out of it, which is mass 1, velocity 1 final, minus mass 1, velocity 1 initial, divided by velocity 2 initial, subtract velocity 2 final. So in my calculator, what I'm going to do is I'm going to do alpha y inner again. I'm going to do open bracket 45, close bracket, open bracket, negative 91, close bracket, subtract, open bracket, 45, close bracket, open bracket, 273. Is there any squares here? No, there's no squares. So let's go down to the bottom. 0 minus 182. And when I hit enter, I got 90. And that is my answer. So what you have to do now is I did questions 1 and 2. And so now what you're going to do is you're going to do question number 3 in here and question number 4. So if you look over here, it's going to tell you what question number 3's answer is and what question number 4 answer is. So what I want you to do is I want you to be able to look at this, and I would like you to try those problems and submit it online. So that is the end of today. But let me tell you, you need to practice those problems. You need to take a picture of it and submit it on Google Classroom. And I will see you tomorrow.